Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of powers, specifically how we can multiply them, and we'll do it in 5 minutes or less. So we have a sample here of two different expressions we're needing to multiply here. This we're going to count as 1, and then we're going to count this as 1 as well. How do we multiply these things, right? We know how to multiply 3 and 4, but what do we do with the x's, the y's, and the z's? Well, when we're dealing with a lot of exponents or powers, right, we need to keep this in mind with multiplication. And so if we look at our mathematics chart or our reference materials, we're going to see something that looks like this. A to the m times a to the n equals a m plus n. Okay? What exactly does that mean? Well, when you have two expressions that you are wanting to multiply and they have the same base. Now, we need to make sure that we have the same base. The base is the big number when we're dealing with exponents, right? The power or the exponent is going to be the small number. You can add the two powers, m plus n, when you're multiplying, but it has to have the same base. So we're looking for like terms. So over here, we're going to be dealing with x's and x's, okay? And then y's, put a box around those, and y's, put a triangle around z's and z's. Then we can just deal with the numbers, the coefficients, just like normal. But the bases need to be the same. And when these two are multiplied by each other, it's like the two powers are being added together. So that's what happens when we multiply powers, okay? So let's just see what happens here. I'm going to merge these, and I'm going to look at each base separately, right? So this 3 times 4, I can just kind of handle that right there. 3 times 4. Now let's see what happens with my x's. I've got x to the second power, and then I've got x. There's nothing right there. But whenever there's not an exponent there, we can always assume it's to the first power. So I've got an x to the second power, x to the first power, so I'm going to add those two. Then I'm going to do the same thing with my y. I've got y to the third. There's nothing right there, so I'm going to assume it's to the first power. So that's 3 plus 1. And then my z is to the first power. Then I've got to the third power over here, 1 plus 3. So let's simplify this. 3 times 4, right, is going to make 12. That's x, 2 plus 1. That's going to be x to the third. And then my y is going to be to the fourth. My z is going to be to the fourth, because I was just looking at bases that were the same. I had 3 different bases, the x and the y and the z. How do we know this is correct? Well, let's just substitute a little bit, right? Let's just say our x's are going to be 1, our y's are going to be 2, and our z's are going to be 3. And let's just substitute in. This is our final answer, but let's see our original answer. All right, so 3. All right, so our x is 1, so let's do 1 to the second power. And then I've got y is 2 to the third power. And then z is just 3. Okay? Then I need to multiply all of this by 4. X is just 1, y is just 2, and then z is 3 to the third power. Okay? So that's the original. So theoretically, this should equal what I came up with, right? The simplified version, 12, and then that's going to be x, which is 1 to the third power, and then y is going to be 2, right, to the fourth power, and then z is going to be 3 to the fourth power. And if I can simplify both and make sure that they're equal, well, then we're going to be the same. So let's go ahead and take a look at what this turns into. So this first expression was 72. The second expression was 216. Right? So if we were to multiply those two, that's going to be 72 times 216, 15,552. This other one over here, I just simplified each of those powers. 12 times, well, 1 is just 12, times 16 times 81. And guess what that makes? 15,552.